So we'll go ahead and get started with the review. Okay, so the practice test should be on your screen now.
Yes, it's up.
Okay, awesome. So for this first problem, when you're doing a square root of a fraction, the easiest thing to do is to take the square root of the numerator and the square root of denominator and then just leave your answer as a fraction. So there's a negative out front already. Sorry, I'm not at my own house, so I can't answer the phone. Okay, I'm so sorry about that. The negative stays out front. And then what is the square root of 1?
Isn't it just 1?
Yes, very good, because 1 times 1 is 1. And then what is the square root of 4?
2.
2. Yep. So your answer here would be 1/2, and then the negative stays out front. For number 2, you would be able to just type that directly into your calculator. Do you guys have calculators with you right now?
Yes.
Okay.
Yes, but for tests, I don't think we're allowed to use our calculators.
You're not at all?
Not for the one I took.
Okay. We used to allow people to use calculators in this course. I don't know if they've changed it at all.
We just have the calculator that's online.
Yeah.
Okay.
That we can
Which
use.
they it should pop up for this question, or did it not?
It pops up for every question, I'm pretty sure.
Okay, okay, gotcha. Okay. So now I see what you're saying. You can use the one that's online, but you don't have to necessarily have your own in front of you right now. Got it. Okay, so you can also use a phone right now if you need to. So what is the square root of 0.0121 on your calculator? Were you able to do it, Chloe?
Not really.
Okay. Did you say you had a calculator?
Yeah, but
Okay. Go ahead.
I don't really know what to do.
Okay. Can you show me your calculator? Do you have a camera that works?
I just have my phone calculator.
Okay. On your phone, what you'd be able to do is you should be able to type in the 0.0121 and then hit the square root button. Marla's here. Hi, Marla.
Hi.
We have a couple new students joining us.
Nice.
So, but Marla's done all the reviews with me, so we're like best buddies now. So you didn't miss much.
1-1.
So 0.11. Very good. Number 3, there's a negative out front, so that's going to be part of our final answer. And then what is the square root of 4?
2.
2. Yep. So our answer will be -2. Now for variables, let me do these 2 problems. Let's see. One way to think about the last problem, right, is you could think of the square root of 4. I know you didn't do this, but you could think of it like you broke down the 4 into 2 times 2, right? And because there was a pair of 2's, that's what allowed you to get a 2 outside of the radical as your answer. You can do that strategy here in case you want to tie the variables back to what you do with regular numbers, because x to the 8th is actually 8 x's, right? Being multiplied together. I think that's only 7. 8. So you can think about it that for each pair, you bring an X to the outside, right? So you can be like, okay, well, there's 1 pair here, 2 pairs here, 3 pairs here, 4 pairs here. That's 4 pairs of X's. So that means there's going to be 4 X's or X to the 4th outside the radical. But the shortcut that we teach you is that a square root is really like having an exponent of 1/2, like you learned about. So you can really just take the 8 and multiply by 1/2, which is the same as saying you can take the 8 and divide by 2, which is the shortcut that we teach you, that you can take whatever your exponent is. And if you're doing a square root, just divide it by 2, but it's really because you're looking for those pairs. Okay. If you guys have any questions, don't hesitate to ask, okay? So we're good so far? Okay, what about this one? Negative the 4th root of 16. So what number times itself 4 times gives us 16?
2.
And then the negative stays, right? So it'd be -2. I'm sure we'll get to it later, but what would happen if I had given you this problem? What would happen if I moved the negative inside the radical?
You'd have to pull out the negative.
So you can do that when you have what kind of root?
Oh, I'm thinking of more further out.
Yes, but also it only works with square roots.
Yeah, so that's
Mhm.
you can't solve that. That's
Correct. That'll be not real. If it was this problem. Because if you took -2, let's say you thought that would be the answer. The problem is when you multiply -2 by itself 4 times, you end up with a positive 16, not a negative 16. So there's no way to get back to the negative. Okay, this one, there's a couple ways to do number 6 and 7. One way is to actually work them all the way out, or the other way is to know the shortcuts. And we can go over both ways because it doesn't hurt. So if you don't remember the shortcuts, which is fine, -6, when you square it, becomes positive 36, right? And then what is the square root of 36?
6.
6. Okay, and then for the other one, -6 cubed is -216. And what is the cube root of -216? If you have a calculator, it'll tell you that the answer is -6. The shortcut is when you do a root of a power, they cancel out and you just get the number. But if it's an even root, like in number 6, where this was an even root and an even power, then you get the absolute value of the number. If it's an odd root, here you had a cube root and a 3rd power, then you get the actual number. You don't get the absolute value of the number. But if you don't know the shortcut, not a big deal. I wanted to show you can still work it out.
Wait, how did you get -6?
The cube root of -216. So you would do that on your, potentially on the calculator. I'm not sure what capability your calculator has. The other way is you could work backwards. So you can make yourself a table. Sometimes I recommend this depending on what your calculator does, because you can always work forwards. So 1 cubed, you could do 1 times 1 times 1 on your calculator and it would tell you the answer is 1, right? And then 2 cubed, 2 times 2 times 2, you could type into your calculator and it'll tell you the answer is 8. 3 cubed is 27. So even if your calculator does not have a cube root button, I'm not sure exactly what functions are on your calculator, you can always do this, right? Because you can always multiply on the calculator. 5 cubed, 5 times 5 times 5, you would type in, is 125. And then 6 cubed is 216. You could keep going. I'm just going to stop there because that's the number we needed. That means if 6 cubed is 216, that tells you that the cube root of 216 is 6.
Got it. Thank you.
But that's a great way to make that list to help you with these problems, especially if your calculator does not have a cube root button or a 4th root button. That's the way to do it, is work, kind of list them out and then work backwards from these numbers to come up with these numbers. Okay, so let's check out this one. Number 8, square root of 49, a to the 8th power, b to the 40th power. So first, let's just do the number, then the a's, and then the b's. So what is the square root of 49?
7.
7. Very good. And then how would you handle a to the 8th?
A to the 4th.
Very good. Divide the exponent by 2. Good. And then the square root of b to the 40th.
B to the 20th.
Awesome. Nice job, guys. Okay, what about the next one? The square root of 4/25.
Wouldn't you like separate the square root to where it's square root of 4 on the top and then square root of 25?
Very good.
Then it would be 2/5, right?
Yes, very good, guys. What about this one?
Don't you break it up the same way?
Mm-hmm. Very good. So what is the square root of x squared?
X.
So for the denominator, what do we get?
9y.
9y. Good. Okay, for number 11, we're going to write the expression using radical notation. So I just mentioned a minute ago, but m to the 1/2 is the same as what kind of root?
Square root?
Square root. Very good. So this would become, so this is my question. Which of these answers is correct? This answer or this answer? So is it the square root of 5m or 5 times the square root of m? Which answer is correct and why?
The 5 times the square root of m.
Very good. Why is that correct, Marla?
Because the half is only the exponent for the m.
Good. So for this problem, that would be the answer. Very good. For this, it would have to say 5m in parentheses raised to the 1/2 for the 5 to also move inside the radical. Very good. So if you have a 1/2 power, it's the same as a square root, but we normally don't write the little 2. So it's assumed if you just write a radical without a little number that there's a like invisible 2 there, right? So here, when you have a 1/3 power, that means that you're doing a cube root. So you have a cube root of -125, which you might have that button on your calculator, or we can go back to the list I made a few minutes ago. So based on this list right here, what is the cube root of 125? We'll worry about the negative in a second, but what is the cube root of 125?
It's 5.
5, right? So we can use the list to figure out the answer. So you can do that, make the list once on your test and then refer back to it if needed. So then here, since it was the cube root of -125, the answer would be -5, right? Because the negative times the negative times the negative again does give you a negative answer. Okay, how would you rewrite number 13?
Wouldn't it be 6 on the outside and then radical and then inside the radical negative 64.
The negative would be on the outside.
Yeah, yeah. Thank you.
Very good. Yes, the negative would be on the outside because kind of like the problem that was 5m to the 1/2, right? Only the m was being raised to the 1/2. Here, only the 64 is being raised to the 1/6 unless the negative was in parentheses with the 64, but it's not. So it's on the outside. So what is the 6th root of 64? And this one you could also work backwards and say, okay, what is 1 to the 6th power? What is 2 to the 6th power? Until you come up with the 64.
It's 2.
It's 2. So your answer here would be -2. Very good, because 2 times 2 times 2 times 2 times 2 times 2 is 64. Good. What about number 14? How would you rewrite that?
So that would be 4 on the outside to negative 81. And then it's cubed. The 81 is cubed.
Very good. So the denominator is your root. The numerator is your exponent. So in the other problem, since the numerator was 1, that's why we never had to write an exponent on the inside. But this time we do. What do you know about this answer, though?
The answer is not a real number.
Why is it not real?
I went over this with my aunt because she's a math teacher, but she said that if it's an odd, I think, exponent, then it's not real.
So if it's odd, you can work it out like in, let's see, this problem, number 12, right? If you have an odd root, you can get an answer. If it's negative, you'll get a negative answer. But if you have an even root, and this ends up being negative even when you cube it, so if you have an even root of a negative number, that's when it's going to be not real. Because there's no way, if you multiply a negative number an even number of times, it always gives you back a positive answer. That's the problem. So you're not going to get back to a negative answer. How would you rewrite number 15? With positive exponents only. How can we get rid of that negative exponent?
Do you divide it?
Yep, throw it down in the denominator to make it positive. Yep, 1 over x to the 3/4 power. Very good. So these are rules that you learned before back in module 3, right? You learned the exponent rules. The difference now is that we're now using the same rules with fractions as your exponents instead of just integers as your exponents. So when you multiply, what do you have to do with the exponents in number 16?
Or you just add them across.
Add them across. Good. And the good news is they have a common denominator, right? So what is 3 over 7 plus 8 over 7?
11 over 7.
Very good. Add the numerator, keep the denominator the same. So that's your answer, d to the 11/7 power. So let's do the same thing for number 17, right? We're multiplying, so we're going to add the exponents together. So what is -2/5 plus 7/5?
Wouldn't it just be x because it would be 5 over 5?
Exactly, it'd be 5 over 5, which is just 1, right? So then you would have like x to the 1st power, which I agree with you is just x. Very good.
Is there another way to get that?
Yes. Did you think of it another way, or you want me to show you another way?
Can you show me another way?
Yes. Then you could think of the x to the -2/5. So I'm going to keep this in the top, but you could move that to the bottom, kind of like we did a problem or two ago with the 3/4 when it was the exponent.
Oh, okay.
And then you could actually subtract them. That would be another way you could do it.
Okay.
So you could do 7/5 minus 2/5, which still gives you 5/5. So you still end up with the same answer.
Okay.
But if that's another way to conceptualize it, which I actually think you sometimes do the problems like that, don't you? Isn't that how you were doing them
Yeah.
in the third module?
hmm
So yeah, that would work also. Okay, so what do we need to do in number 18 here?
Don't you multiply to get the denominators the same?
Mm-hmm. And then what are we going to do with the fractions?
Subtract.
Subtract them. Very good. But you're absolutely right. We would need to get a common denominator. So we're going to have to do 1 over 10 minus 1 over 20. So how could we turn 10 into 20? What do we need to do?
Multiply by 2.
Good. So now we have 2. Oh, I don't know why I wrote 20. I'm sorry. I jumped ahead of myself. Now we have 2 over 20 minus 1 over 20, which gives us 1 over 20. And of course, all of that is our exponent, right? So our answer would be y to the 1 over 20th power. So any questions so far? I feel like this chapter starts out with a lot of quick problems, but they use a bunch of different rules. And then it gets into some pretty complicated stuff by the end, right? So it's an interesting mix. Use the product rule to multiply. So we just need to multiply what's inside the radical. So what is the square root of 7 times the square root of 6x?
There'd just be 42x.
But don't forget
Well,
what?
squared or square
Yeah.
root.
Square root of 42x. Good. And then number 20 is kind of similar to what we've already done, right? Where we've talked about where you have to take the square root of the top and the square root of the bottom. The only difference here is we cannot simplify the square root of 3 because it doesn't work out cleanly, but we can simplify the square root of 25. What does that give us?
5.
5. So the answer here would be square root of 3 over 5. Be careful when you type this into my math lab that only the 3 is under the radical. So there is a difference between inputting that answer and inputting this answer, right? So you have to be careful when you type it in that you're not putting the whole thing under the radical. Okay, now we're going to add and subtract some radicals. When you're adding and subtracting, what is really important?
What's inside the square root?
Has to be what?
It has to be the same.
Has to be the same. So the first thing we need to do here is simplify both radicals to see if we end up with the same value inside each radical. So what can you simplify if you look at the first radical? What's the only thing that can be simplified?
The x.
So how does that become simplified?
It would be a 2x.
Inside the radical, it becomes 2. The 2 stays, and 1x remains, and then what else happens?
On the outside is a 2x. Or wait,
On the
5x. 5x. My bad.
So a few ways to think about that. One is you are taking the 3, the exponent, and dividing it by 2, like we did before. And that gives you 1 with a remainder of 1, which tells you that an x goes on the outside and also an x stays on the inside. So that's one way to do it, is that you're kind of doing like good old fashioned division and seeing like, okay, this 1 is the exponent on the outside, the remainder is the exponent on the inside. Okay, that's one way to do it. Or you can even do the trick I mentioned earlier, that x cubed is really 3 x's, right? So there's a pair of x, so that tells you an x goes on the outside and this x stays on the inside. There's other ways you could think about it, but those are at least 2. Okay, how about the second radical? How could we simplify it?
You can pull a 2 out.
Yes, so the 8, several different ways. You can either think of the 8 as 4 times 2, right? And therefore the square root of 4 is 2, right? So you can think of it as like 9x square root of 4 square root of 2x, kind of separate it like that because 4 times 2x is 8x. But then the square root of 4 is 2. I'm with you. And then you have to multiply that by 9x. So what does that actually give us on the outside?
So you have an 18x and then the square root of 2x.
Good. So now I'm bleeding into the next problem, but that's okay. We'll adjust that in a second. Now you have 5x square root of 2x plus 18x square root of 2x. So now all of your radicals are the same, right? Both terms have an x square root of 2x. So you can actually add the coefficients. So what is 5 plus 18?
23.
So your final answer here is 23x times the square root of 2x. Any questions there?
No.
No. Okay, while I'm rewriting it, why don't you guys see how far you can get with number 22? So 4 times the square root of 27 minus 2 times the square root of 18 plus the square root of 75. I'll rewrite it off to the side for us. How would you simplify the square root of 27?
So you can pull a 3 out of that.
So you could split it up into 9 times 3. And then this, you're looking for perfect squares that go into it, right? So the square root of 9 is 3. So that whole term becomes 12 times the square root of 3. Good. How about the square root of 18? What could you pull out of that?
3.
Okay, and then 75.
A 5.
Good. 75 is 25 times 3. So I agree with you that you get a 5. Okay, so now you have 12 square roots of 3 minus 6 square roots of 2 plus 5 square roots of 3. Is that our final answer?
Nope.
No, because we need to combine like terms. So which terms can be combined here?
You can add the 12 to the square root of 3 to the 5 of the square root to 3.
And what does that give us?
Yeah, it's 17 to the square root of 3.
Minus 6 square roots of 2 just gets brought down, but it can't be combined because the one term has the square root of 3 and the other term has the square root of 2. Any questions there?
No.
Okay, what about number 23? There's actually a lot that can be simplified there. So what is the square root of 9? So what is the square root of 9?
3.
3, good. And then what is the square root of b cubed?
Wouldn't it be a b on the outside of the radical and then a b on the inside?
Exactly. Okay, what about the next term? Do you want to keep going, Alyssa?
Sure, it would be 5b and then radical b.
Good, and then the last term.
And then negative 9b radical b.
Good. And then what would you do from there?
Would you just combine all of them?
Mm-hmm. So 3 plus 5 is
8,
minus 9.
negative 1.
So you could either write it like that, negative 1, b square root of b. They would accept that, or if you didn't have the 1 there, that would also be fine. Negative b square root of b. Great job, thank you. What about number 24? How could we simplify the square root of 54x? Chloe, are you there?
Yes, I'm here.
Okay. Do you want to try this one? What goes into 54? What perfect square goes into 54?
Can I work this out on my calculator really quick?
I don't know if your calculator will do it for you and give you an exact answer, especially because there's variables involved. But you can use it to help you figure out what divides evenly. So do you know your perfect squares? Like 1 squared is what?
2 or 1
1, okay. 2 squared, or 2 times 2?
is 4
Good. 3 squared?
is 9
4 squared?
16
5 squared?
is 25
Good. 6 squared?
is 36
7 squared?
is 42.
49.
Okay, 49.
8 squared?
64.
Good. We'll stop there. There's more, obviously, but we'll stop there. You're looking for what number that when you divide it, you get an answer, right? That you don't get a decimal, but you get a whole number as your answer. So you can, if you want, use your calculator and go, okay, if I do 54, you know, obviously you can't divide by a number bigger than it, right? So 54 divided by 49, okay, that's going to give me a decimal. 54 divided by 36, that's a decimal. 54 by 25, that's a decimal. And you want to find the biggest perfect square that divides evenly into 54. So do you know if any of these numbers divide evenly into 54? And you can use your calculator if you would like, that's fine.
So you can do, well, 9
Very good.
and 6.
Exactly, very good. So you can split up 54 as the square root of 9 and the square root of 6x, because the x doesn't simplify, right?
Right.
All over 4, good. And then I'll go ahead and finish that part and then we'll deal with the other fraction. What is the square root of 9?
3.
3, good. So the whole first fraction becomes 3 times the square root of 6x all over 4. Now let's look at the second fraction. Remember we talked earlier that when you're doing the square root of a fraction, you can do the square root of the numerator divided by the square root of the denominator. So we're going to leave the square root of 6x alone. But then what is the square root of 4?
2.
2. Very good. So in order to add these fractions together, what do we need to do next?
So we need to multiply the 2.
Mhm. And that multiplies on the outside. What I mean by that is the first fraction is going to stay the same, but the second fraction is going to become 2 times the square root of x, because it's not the square root of 2. If it was, we were multiplying by the square root of 2, then you would actually multiply it with the 6x inside the radical, right? But this is like a separate world. I like to say the 2 is outside the radical, so it can't just magically jump into the radical. So it stays outside. 2 times 2 in the denominator is 4. Now that we have a common denominator, we can add the numerator together, right? So the 4 stays in our denominator. And what does the numerator become?
So it'd be 5
Very good.
and then radical 6x.
See, you got it. Nice job. Okay, so now we're going to find the domain of some radical functions. And what is the key thing we talked about? That when you take a square root, what can you not take a square root of? And get a real answer. It might give you an imaginary answer, right? But what can you not take the square root of if you're trying to get a real answer?
Is it a negative?
A negative, right? So that's why when you're trying to find the domain, which is the same as saying what x values am I allowed to plug into this function in order to get a real number as my answer, we say that the whatever's underneath the radical has to be greater than or equal to 0, right? It has to be positive or 0. It's not allowed to be negative, because we know if you take the square root of a negative number, you get an imaginary answer, and we're trying to get real answers. So how do you solve that for x? How do you get the x by itself on one side of the inequality?
Don't you just add the 9 to the other side so that way x is by itself?
Yes, very good. Oh, there's more people on here than I realized. Okay, very cool. So we add 9 to both sides. So what does that give us?
X is greater than or equal to 9.
Good. Then they want the final answer in interval notation, right? If it helps you to figure it out, you're not required to graph it, but if it helps you, you can think of this like we have a number line. We're starting at 9, and you guys use brackets and parentheses on your number lines, right? So it would be a bracket, right? This is the course that uses the brackets and parentheses, I think.
Yes.
Yeah, okay. I always have to check that with you guys because the other course doesn't. Okay, so if it helps you, you can graph it first to see that, okay, we're starting at 9 and then we're going forever positive, forever to the right towards positive infinity, because once you graph it, it kind of has all the pieces there, right? Then you have a bracket with the 9, because you always have to read from left to right, going up to infinity. And with infinity or negative infinity, you always use parentheses because you cannot equal infinity, which is what the bracket would mean, that you can equal it. So how would you do number 26? And feel free, Allison, Caitlin, Vivian, I just realized you all were here. Feel free to jump in.
You would set it up the same as you did for number 25. You'd put x minus 6 is greater than or less than, or greater than or equal to 0.
Good. And then how would you solve it, Caitlin?
Add 6 on both sides.
Good.
And then create the number line to find the interval notation.
Okay, good. We can do that. So what would you put on the number line?
You would put 6 in the middle.
Mm-hmm.
And then you would use the bracket because it's included.
Mm-hmm.
And then you would go to the right because x is greater than 6.
Very good. So then how would you write it in interval notation?
You would have the bracket 6 and then infinity with the parenthesis.
Excellent. Thank you.
You're welcome.
Okay, so any questions on finding the domain there? Okay, so let's check out number 27. What would probably be a good first step in number 27?
Finding the square root of 4, which is, well, square rooting 4, which is 2.
Very good. So that becomes 5 times 2, right? Minus 2 plus the square root of 2. What is 5 times 2?
10.
10, good. And then we have 10 minus 2 plus the square root of 2. So what does that give us?
8 plus radical 2.
Exactly. Can that combine?
No.
No, because they're not like terms, right? The one is just a whole number, the other's a radical, so they cannot be combined. Very good. So that would be the final answer there. For number 28, am I just squaring the square root of 6 and squaring the square root of 5? Or is
No.
there more going on? No, very good. So we have two options here. We can either think of it as, remember, squaring something is the same as multiplying it by itself, right? So we can write it out as square root of 6 minus square root of 5 times another square root of 6 minus square root of 5, and we can FOIL. Or if you're looking to use the shortcut, you have to remember that there's a middle term, that yes, you can square the first term and square the last term, but then in the middle, you have to have, in this case, minus 2 times their product. So there would be that middle term there. Okay, so let's say we decided to FOIL. What is the square root of 6 times the square root of 6?
6.
It ends up just being 6. Very good. So anytime you multiply square root by itself, you do get the number on the inside. Because if you even work it all the way out, square root of 6 times the square root of 6 is the square root of 36, which ends up being 6. And that will always happen. So the square root of a number times itself just gives you that number, especially if it's a positive number. If it's a negative number, that's when those other rules apply that we talked about earlier, where you have to check if it's the absolute value or not. Okay, so now let's do the outer term. What is the square root of 6 times negative square root of 5?
Negative square root of 30.
Good. 6 times 5 is 30. They're both underneath the radical, so you can multiply them together. Awesome. What about the inner term? Negative square root of 5 times square root of 6.
It's the same, negative square root of 30.
Awesome. And then the last term, negative square root of 5 times the square root of, times another negative square root of 5.
The positive 5.
Excellent. So negative times a negative gives a positive. And then you're using that shortcut. The square root of 5 times square root of 5 just gives you the number on the inside, which is 5. Because the square root of 25 would just be 5. Okay. Is there anything to combine here?
Yes.
Okay, now be careful. I have seen students combine things incorrectly at this step, so be very careful. What can we combine?
The 6 and the 5.
6 and the 5, which gives us what?
11.
Okay. Now, what about the negative root 30 and negative root 30? Can they be combined, and if so, how?
Yes. There's a 1 in front of those technically, so you would add them. So it'd be a negative 2.
So you can think of them both as having coefficients that are invisible ones. So I agree with you, Marla. It would be negative 2 square root of 30, because it's like, you can think of it if you had like minus x, that would be negative 2x. So it's the same idea, except instead of x, you have the square root of 30. It does not become, and this is something I see a lot, it does not become negative square root of 60. So you cannot just like add or subtract the numbers inside the radicals together. Remember, with radicals, you can only combine them if what's inside the radical is the same, and then you're just adding or subtracting the coefficients on the outside. Okay, so let's try number 29. Here we're just distributing. So what is the square root of 14x times the square root of 14?
Do you multiply the 14 and the 14?
You could, or you could use the trick, right? What's the trick? That anytime you have a radical times itself, just pretend the x isn't there for a second, that the root 14 times root 14 is just going to give you the whole number 14. Because if you multiply them together, I believe it's 196. And then if you take the square root of 196, you get back to 14. But the x is still underneath the radical. So I kind of regrouped it in my mind. Let me write it out in case it makes sense. Where I kind of separated the 14 and the x and the 14 for that first part. And that's why I kind of ignored the x for a second and just dealt with the 14s. Okay, now we have to distribute it again. And then this time, what happens?
That x's cancel out?
So the x comes outside, right? Because you end up having two x's, right? So that time you had two 14s. This time you have two x's underneath the radical. So an x comes out, and then you're left with the square root of 14. Any questions there? Okay, number 30, we're gonna need to FOIL here again, right? So let's jump right into it. What is 3 square roots of x times 9 square roots of x?
Mm. 27x.
Very, very good. So 27, because 3 times 9 is 27. And then square root of x times square root of x, anytime you multiply something by itself, it just comes out of the radical. So excellent, 27x. Okay, outer term, 3 square root of x times negative 3. The 3's are both outside the radicals, so they can be multiplied together, right? So what is 3 times negative 3?
Negative 9.
Negative 9, and then there's a square root of x attached. So I like to focus on that. Like I say, what world are we in, right? If it's under a radical, then it can be multiplied by something else under a radical. But if it's not, then it multiplies together on the outside, right? So you have to pay attention to where everything is. How about here, 8 times 9 square roots of x? What does that give us?
It'd be 72 and
Good.
then
Well,
radical x.
multiply the numbers on the outside. Good. And then 8 times negative 3.
Negative 24.
Okay. Are there any like terms to combine?
Yeah.
Yes. What can be combined?
The negative 9 radical x plus 72 radical x.
What does that give you?
63 radical x.
Okay. Anything else that we can combine? I agree with you. Nice job. So the x is different from the square root of x is different from the term that doesn't have either. Very good. So they cannot be combined. So that is your answer. Any questions? A bunch of you are quiet. Any questions? No? Okay. Now we're going to rationalize the denominator. This is based on the fact that back in the day, it was easier to, when you had a long decimal, it was easier to be multiplying by a long decimal than it was to be dividing by a long decimal. The good news is nowadays you have calculators, so it doesn't really matter, but it's still a practice that we adopted back in the day that we still seem to use nowadays, which is we don't like to leave radicals in the denominator. So in order to do that, the trick is that you multiply the radical in the denominator by the top and the bottom, because that will cause the radical to basically disappear from the denominator. So what is the square root of 3 times the square root of 2?
Square root of 6.
Uh-huh. And then what is the square root of 2 times the square root of 2?
2.
Just 2, right? Because it's the square root of 4, which is just 2. Very good. And that would be your answer. So when it's just one term in the denominator, you just multiply it by that term, top and bottom. You do it top and bottom, right? Because you're really just multiplying by 1. So you're getting the problem in a different format, but you're not changing the problem per se. Okay, number 32, when you have multiple terms in the denominator, in order to get rid of the radicals, you need to multiply by the conjugate, which means you need to change the sign in the middle. So we're going to multiply by the square root of c minus the square root of m, top and bottom, because as you'll see when we work it out, that will ultimately cause the radical to disappear from the denominator, which is the goal. So in the numerator, we're going to distribute. So what is the square root of c times the square root of c?
C.
C, good. Minus, what is the square root of c times the square root of m?
Square root of cm.
Very good. All over, and then in the denominator, we're going to FOIL. So what is the square root of c times square root of c?
C.
Just C.
Good. And then square root of c times negative square root of m.
Negative cm.
Negative square root of cm, good. And then the inner term, square root of m times the square root of c.
Does it matter which way the variable goes?
Good question. We'll go ahead and just write it in alphabetical order. So you could write it as MC or CM, because when you're multiplying, the order doesn't matter.
Okay.
And then the last term, square root of m times the square root of m.
That's minus m.
Just minus m. Very good. So what happens in the denominator, which is actually good news?
The middle terms cancel out.
And that's what should always happen. If you correctly multiply by the conjugate, the middle term should cancel out, and all the terms that you're left with in the denominator should be radical free, right? There should be no radicals. And that was the goal when you wanted to rationalize. So it's okay to end up with radicals in the numerator like we have here. It's not okay to end up with radicals in the denominator. Is there anything else that we can do here?
No.
I agree with you. The C's do not cancel, even though it might be tempting, right? Because remember, terms only cancel if the whole thing matches, right? When you have addition or subtraction, which you have here, you can only cancel things out if it's completely identical top and bottom, not just one part of the sum or difference. So very good. That is the final answer. Okay, so now we're moving on to complex numbers, where we're going to express in terms of I. So what is the square root of negative 25? And let me remind you, I said it once earlier, but to help keep things clear on the test, the I is only for square roots, okay? Square roots of negative numbers. So if you see a fourth root of a negative number, the answer is not real, okay? But if you see a square root of a negative number, then you are able to evaluate it. So just keep that in mind on your test. So what is the square root of negative 25?
5i.
Very good. Square root of 25 is 5, and then the square root of the negative means you pull out an I, because you learned that I equals the square root of negative 1, right? So you can technically think of this as square root of negative 1 times the square root of 25 if you want to help you get your answer. Okay, what about the square root of negative 11?
It's a square root of 11, I.
And you can write it either way. So you can either put the I afterwards or the I beforehand. The key thing you cannot do is this. Why is this answer wrong?
Because I isn't included in the radical.
So as long as you put I outside the radical, it does not matter if you put it before or after the square root 11, it just cannot be inside. Okay, what about this one?
Negative 11.
Negative 11. Why did you not include I in your answer?
Because the negative sign is outside of the radical.
Excellent. How about the square root of negative 49 in number 36? What would that answer be?
7i,
And why did you include I in your answer?
because it's a negative inside of the square root.
Exactly. So really, we're using the same rules you learned for square roots before, right? At the beginning of this lesson, except that now sometimes I is involved if you're doing a square root of a negative number. So how would you simplify number 37?
Would you break it apart and make it like 3 times 9 times a negative 1? And then that way you can square root the 9 and bring out the 3.
Exactly. So bring out a 3. So the square root of 3 stays. This 9 becomes a 3. The square root of negative 1 becomes an I, right? And then when you multiply all that together, what is your final answer?
Hold on 1 second. I'm just typing it in. It gives you 24 square root of 3, and then would the I be on the outside? It would be on the outside of the square root because it's not a part.
So you could either put it like that or put it like this, for example. I sometimes write the I's in front of the radical because I would personally be afraid that I would forget to use that right arrow to move outside the radical if I was typing it into my math lab. But it is perfectly valid to have it at the end as long as you do not put it inside the radical. Okay. Now, when you're multiplying and dividing with radicals, it is important that the radical you're working with is of a positive number if you're dealing with square roots. So what I mean by that is the rule only works that you can multiply them together or divide them together when they're real, not when they're imaginary. So the first thing you need to do is actually simplify each radical, and then you can go ahead and do the multiplication. If you multiply them as is, it's very possible that you'll get the wrong answer. So you might get the right answer, but you might also get the wrong answer. So it's better to kind of aim for the right answer every time, right? By simplifying them first. So how could you simplify the square root of negative 5?
5i.
Pull out an I, right? Oh, it's feels very violent in this lesson, right? We're pulling out a lot of I's. Just the letter I, right? Not our actual, not EYE I's. So you will not be harmed, right? Do I need to say that at the beginning of the lesson? You will not be harmed by participating in this lesson. Okay, how about the square root of negative 35?
Same, you pull out the negative.
Okay, now when we multiply them together, we have I times I. What is I times I on the outside?
I squared.
I squared, very good. And then what is, it's the square root of 5 times the square root of 35?
The square root of 175.
Okay, good. Now we still have more work to do. What does I squared equal?
-1.
-1, good, because I is the square root of -1. You can think about if you square both sides, that means I squared equals -1. So now you have a negative on the outside. You don't need to write the 1. And then let's break down the 175. What's the largest perfect square that goes into 175?
25.
25. 25 times what?
7.
Good. So then what is the square root of 25?
5.
5. So the final answer would be -5 times the square root of 7. Questions? No? Okay. Number 39. Once again, let's simplify each radical first and then multiply. So what is the square root of 36?
6.
Okay, what is the square root of -1?
I radical 1.
It would be I radical 1, but what is the square root of 1?
1.
1. So it really just becomes I. So then what is 6 times I?
5.
6i.
6i. Really not much going on in that problem compared to the last one anyway. Nice job, guys. So let's try number 40. We're going to simplify each radical. In fact, I'll give you a minute. See if you can simplify each radical and then see what cancels out when you divide. So how could you break down the square root of -90? Vivian, did you get it?
Yeah, I'm trying to figure out like I know what I'm doing, but like explaining it is
Okay.
an issue.
That's fine. Well, what did you write as your next step? You can just read it from your paper.
I put I in front and
Okay.
took away the negative of it.
Okay, good. And then can you break down 90 at all?
Yeah, I broke that down into 10 times 9.
Okay, perfect.
And then you can break the 9 down to 3.
So I'm going to write it as 3i
Right.
square root of 10. Yes. Okay. And then what could we do in the denominator?
I only worked the top on the
Okay,
first.
no problem. Someone else want to jump in and help us with the denominator?
Make that a 5i.
So pull out the I. So I times the square root of 5. Okay, so now what can we do? Does anything cancel out?
The I's.
The I's cancel out for sure. Anything else?
Can you divide the 10 by 5?
You can, because they're both inside a radical. So technically what you're doing, you know how we normally take a fraction and then we split it up into 2 different radicals? Here, you're actually kind of doing the opposite. So you're doing it in your head. You're probably not writing this out, but you're actually combining the 2 radicals back into one in your head without realizing it, because you probably did not picture that. But then 10 over 5 is actually what? 2. So I certainly would not expect anyone to write this step, but that's technically kind of what you're doing, that you're dividing them. You're using the quotient rule there. But yes, so you can basically think, okay, I just divided the numbers. That's what you did. Good. So that would be your answer, 3 times the square root of 2. Okay, number 41 and 42. Let's look at these for a second. How do you know, even if the word add wasn't there, so even if there were no instructions, how would you know that you were adding in number 41?
The addition sign in the middle.
Correct. Even if there were no instructions, how would you know that you're subtracting in number 42?
The subtraction sign.
Okay, what if I made up, I'm just gonna make up a random problem. 2 minus 7i times 3 plus 4i. Even if there were no instructions, what operation am I doing there?
Multiplication.
Okay, how did you know I was multiplying there?
Just from previous classes, I guess.
Yeah, if there's
Knowledge.
no sign there, the assumption is that it's multiplication. I'm making a big deal of it because on problems like numbers 41 and 42, I can't tell you how many times students accidentally multiply, even though all they have to do is add or subtract. So make sure you pay attention. I know I did this when we did polynomials also, that make sure you pay attention to what sign you have in between the parentheses, right? If it's a plus sign, add. If it's a minus sign, subtract. If there's no sign, that's when you multiply. Okay, so in 41, we're just adding, which means we're combining like terms, right? So what is 8 plus 3? So we're going to combine our constants together and then combine the imaginary parts with I together. So 8 plus 3 gives us
11.
11. And then negative 8i plus 5i.
Negative 3i.
Very good. You are required to write your answer in that format. So make sure you pay attention to the fact that when you're dealing with complex numbers, we always ask you to write your answer in the form a plus bi. So the real part first and the imaginary part second. So we don't want you to write negative 3i plus 11, even though it's mathematically equivalent, it's not what we're asking for. Okay, for number 42, whenever we're subtracting, you have to be careful with the signs. So I sometimes recommend distributing the negative as your first step and then combining like terms. You're not obligated to do this, just something that I find works to avoid making mistakes with the signs. So 3 plus 9i, if you distribute the negative, it becomes minus 5 plus 9i, right? Because it changes all the signs after it. But now you don't have to worry about what's going on. You're just combining like terms, right? So what is 3 minus 5?
Negative 2.
Mm-hmm. And then what is 9i plus 9i?
Plus 18i.
Exactly. And then that would be your answer. Negative 2 plus 18i. So help me out. What do we need to do in number 43?
You distribute that negative.
Good. So what does that give us?
You got 9 minus 14 minus 7i.
Good. And then what would you do from there?
You do the 9 minus 14, which you get negative 5
Mhm.
minus the 7i.
Very, very good. What about number 44? How would you approach that?
You would write it out to where it's like two of the same things.
Very good. So 8 minus 6i times another 8 minus 6i, and then we're going to FOIL it. So what do you get when you FOIL? What is 8 times 8?
64.
8 times negative 6i.
Negative 48i.
Negative 6i times 8.
A negative
48i.
Another one. And then negative 6i times negative 6i.
Positive 36i squared.
Excellent. Now we need to look and see if we can simplify or combine any like terms here. So what can we do?
You can combine the negative 48 i's.
So what is negative 48i minus 48i?
Negative 96i.
And then what about the 36i squared? What can we do with that?
Times -1.
Exactly. The I squared becomes -1. So the whole thing really becomes minus 36, right? Because what you can think of is when the I squared becomes -1, you keep the coefficient the same, but you change the sign. So if it was negative, it would become positive. Since it was positive, it became negative. So then what is our final answer?
28 minus 96i.
Good. So now the 64 and the minus 36 combined to 28 minus 96i, and it must be written in that order, right? A plus bi for every answer. Any questions there? Okay. Number 45, finding quotients is actually similar to what we did earlier when you rationalize the denominator. So when there's only one term in the denominator, you can multiply by I. Okay, kind of like when you have a radical, you just multiply by whatever the radical is. So here you can multiply by whatever the complex number is, which in this case is just I. That works if you only have one term. So here 8 times I is 8i. And what is I times I?
I
squared.
And what did we just talk about? What does I squared equal?
-1.
Okay, so what is 8i divided by -1?
Negative 8i.
Exactly. That would be it. Now let's try one that's a little bit more complicated. Now we have multiple terms in the denominator. So we need to multiply by the conjugate. So what would be the conjugate of 7 plus 8i?
7 minus 8i.
Very good. Now the good news is in the top, it's being multiplied by 1. So that doesn't really change much, right? So your numerator is just 7 minus 8i. But in the denominator, we're going to need to go ahead and FOIL. So what is 7 times 7?
49.
And then 7 times -8i.
Negative 56.
56i. And then 8i times 7.
Positive 56i.
Good. And then the last term, positive 8i times -8i.
Negative 64i squared.
Good. So what can we do in the denominator?
Well, you can combine, well, I guess cancel out the 56.
Since one positive is one negative, they cancel out. And this is good news because our goal, remember when you're rationalizing the denominator, your goal is to get the radical out of the denominator. Here, when you're dividing by a complex number, your goal is to get I out of the denominator, right? Which is what we're working on. So what do we know about I squared?
Negative.
So if this is really -1, then this whole last term becomes what? 49 and then what?
Plus 64.
Good. And what is 49 plus 64?
113.
Good. Are we done?
No.
No, why not?
You have to separate into two fractions.
Yes, since they want that final answer in the form a plus bi, it can't all be over c, for example, like it is now. So you have to split it up. A and b are allowed to be fractions. So each term is going to get divided by 113. So you could write 7 over 113 minus 8 over 113 I. If it's simplified, you'd have to simplify it, but 7 and 8 do not go into 113, so you are good to go. They don't have any common factors either. Okay, so any questions there before we move on to the square root property? Oh, just kidding. There's one more. What's negative 6i times 9i?
Negative 54 I squared.
Negative 54i squared. Good. And what does I squared equal?
Negative 1.
So overall, what is your answer?
54.
54. There you go. They just wanted to see if we were paying attention. So now, any questions on complex numbers before we move on to the square root property? No. Okay. Square root property says you can take the square root of both sides. You just have to know that your answer could be positive or negative, which I'll explain why in a second once we actually work this one out. So if you take the square root of both sides, you get x equals plus or minus the square root of 245. The reason it works to be plus or minus is because if it's positive, if you square it, then you still get back to itself. But if it's negative, right, then a negative times a negative is still a positive. So that's why you get two possible solutions, positive or negative. Now, the only thing you have to worry about is you always have to simplify your radicals. And this radical does actually simplify. So if you think of that list of perfect squares that we made earlier, the 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. I'll stop there. So I'll tell you it's one of those numbers. See if you can figure out which one divides evenly into 245.
49.
And feel free to use a calculator if you need to. I hear an answer though.
49.
49, yes. And I could certainly understand if you needed a calculator to do that. That is not something I expect you to do off the top of your head at all. Okay, how many times does 49 go into 245?
5 times.
5 times. Then you have to simplify. What is the square root of 49?
7.
7. And then that's your answer. Plus or minus, which there is a plus or minus button in my math lab. Plus or minus 7 times the square root of 5. You might see them list the answer like this, by the way, 7 times the square root of 5, negative 7 times the square root of 5, which is also correct, but it's not necessary. So you can enter it like this, or if you want to list it like two separate answers, that's also fine. Either answer should be accepted. So what would you do first in number 49?
You would add the 57 to both sides.
So you need to get whatever is being squared by itself as your first step before you apply the square root property. So I agree with you. You want to add the 57 to both sides as your first step. So now 3z squared equals 57. Now whatever's being squared is still not completely by itself because it's being multiplied by 3, right? So how do we undo being multiplied by 3?
Divide by 3.
Exactly.
Both
So we
sides.
divide by 3 on both sides. So what does that give us?
19.
Good. And now how do we solve for z? If z squared equals 19, how do we solve for z?
Square both sides.
Take the square root of both sides. And what does that give us?
Plus or minus radical 19.
Exactly. Nice job. How about number 50?
You just square both sides because it's already in the correct form.
Exactly. Already, whatever's being squared, which in this case is the x plus 9, is by itself, right? There's nothing else extra there. So your first step is to take the square root of both sides. Very good. When you take the square root of something that was being squared, you just get the original thing, right? So x plus 9 equals plus or minus, what is the square root of 16?
4.
4. Now be careful here. The next step could be to subtract. There's two ways to do it from here. So one way is you could subtract 9 from both sides, but I would recommend writing the 9 first. So negative 9 plus or minus 4, and then work it out, right? What is negative 9 plus 4?
The negative 5,
And then what is negative 9 minus 4?
negative 13.
The other way you could have done it instead of solving it together is created two equations. So you could have set up the equation x plus 9 equals 4 and x plus 9 equals negative 4, and then solved both equations by subtracting 9 from both sides, and you would have gotten the same answers that we did the other method. Okay, any questions on the square root property before we dive into complete the square? No. So complete the square, you're trying to create a perfect square trinomial, which it might feel like a random process now, but you will see that it helps you to solve equations. Because if you think about it, quadratic equations, when we first studied them in the last module, they always were factorable. But every quadratic equation that you actually encounter is not always possible to be done by factoring. So we had to establish some other methods that you could use to solve them. So one of them is the complete the square process. And then the complete the square process actually helped us to derive the quadratic formula. So even if you're not a fan of complete the square, the quadratic formula would not exist if someone had not figured out that complete the square works. So it's kind of cool if you think about it. It also helps when you get into studying different shapes like circles and ellipses and things like that. It's helpful to have an understanding of the complete the square process. So it does come up again if you go into like pre-calculus, you might see it again there. You'll see it in college algebra also, but you'll see it applied more when you get further along. However, there is a formula you can use, which is if you have like x squared plus bx, the trick is that you always take the b value, divide it by 2, and square it. And that's going to be your constant. To take your b value, whatever the coefficient of x is, divide it by 2 and square it. And then on the other side, that's always going to equal the number you got when you divided by 2. So x plus b over 2, and then all of that squared. So this is the formula. You can also get this other side by factoring. So I'll explain that when we work through the problem. So m squared plus 22m. 22 is your b value. So we're going to take 22, and the first step we're going to do is divide by 2. So what is 22 divided by 2?
11.
Okay, I think I heard it.
11.
11. Okay, my computer must have cut out. Sorry. And then we're going to square that. So what is 11 squared?
121.
That's what we're going to add here. So now pretend you don't know the complete the square rule and all you know how to do is factor. How could you factor that? What are two numbers that multiply to 121 and add up to 22?
11.
11 and 11, right? So couldn't you write this if you didn't know anything about complete the square, but you just knew how to factor? You might say, okay, so this is really m plus 11 times m plus 11, right? And isn't that the same as writing m plus 11 squared, correct? Just from your knowledge of factoring. However, if you look at the formula I gave you, which you can memorize if you want to, it says that it's always going to factor as x, or in our case, m, plus b over 2 squared. Well, sure enough, what did we get for b over 2? We got 11, right? So it works by factoring or by using that formula, whatever number you got when you divide it by 2. Okay, I like to show that because that way when the numbers are reasonable, it's nice to know that it's okay if you just factor to figure it out. Sometimes the numbers get messier and you're dealing with fractions and things like that. I don't really recommend factoring with fractions, so it is good to know the rule that it's always whatever you got when you divide it by 2. But I like to show that it connects. They're not two separate concepts. They're actually overlapping. They relate to each other. Questions there? Okay. So let's try number 52. Let's actually apply this process to an equation. So the first thing we need to do is I'm going to subtract 76 from both sides because I want to have just the terms with the variable alone on the one side and the constant on the other side. And now I want to figure out what to add here. But if you think about an equation needing to be balanced, whatever you add on one side, you also have to add on the other side, right? Just like you always do when you're solving an equation. Whatever you do to one side, you do to the other side. So let's figure out what number we have to add to both sides. So you want to take the b value, right? What is the b value here?
Positive 18.
Good. Then you want to divide it by 2. So what does that give us?
9.
And then you want to square that.
81.
So we're going to add 81 to both sides. Okay. Now, what is negative 76 plus 81?
The
On the right
negative
side.
58.
Negative 76 plus 81?
Oh, negative 58. Did I do that wrong? No, I did that wrong.
Yeah,
Sorry.
it's not 58.
It's
5.
negative 18. Positive 18.
No, I agree with, I think Caitlin said it. I'm not sure, but it's
Oh, hi.
5.
My calculator skills are failing me today.
Oh, you are fine. No worries. You're just trying to keep us all on our toes, right?
Yes, there you go.
That's what I like to say if I make a mistake. I was just saying if you were paying attention, right? Were you paying attention? Okay, it's a nice excuse. Also maybe a little bit of a lie, but that's okay. How about the left side? You can either factor it or use the trick that I was showing you with the formula. So how would you write it as something squared?
Would that be an x plus 9 squared?
Very good. So if you're trying to factor it, you're saying what numbers multiply to 81 but add up to 18, which would be 9 and 9. So you could write it as x plus 9 squared. Or you're using the formula, which says you always use the value that you got for b over 2. Okay, now what you've actually done is set up a problem where you can use complete the square. Or not, sorry, you've done complete the square. You have set up a problem where you can use the square root property. So these problems kind of combine both, right? You have to do complete the square initially, but then you have to do the square root property to finish out the problem. So now we're going to take the square root of both sides. So that gives us x plus 9 equals plus or minus the square root of 5. And then what would be the last step?
Just subtract the 9 on both sides.
So I would write it as negative 9 plus or minus square root of 5. And you can enter it like that. You do not have to enter it as two separate answers. Okay. Any questions there? Because I know this is a complicated process. Nope. Okay. Let's check out number 53. Unfortunately, what do we need to do first in number 53?
You gotta divide by that 9.
Yep, you cannot have a coefficient in front of the squared term. So we have to divide every term by 9. Doesn't matter that it's nasty. We are required to do it as our first step. So this becomes p squared minus, now 30 over 9 does reduce, and I do recommend reducing it because there's no need to deal with the really big numbers. What little number goes into 30 and 9?
3.
3. So we can reduce that down to 10/3, right? To at least make the numbers a little more manageable. Plus 19 over 9 equals 0. Then we have to do like last time, right? And get the 19 over 9 on the other side. So now we have p squared minus 10/3 p plus, we have to figure out what to add there, equals negative 19/9 plus whatever we decide to add. So how do we figure out what we have to add on both sides?
You divide the negative 10 over 3 by 2.
Mhm. Which is a little bit tricky. 2 is the same as 2 over 1, right? And when you're dividing, if you recall, that's the same as multiplying by the reciprocal, or you can think of this as a keep, flip, change problem, right? So we're going to keep the first fraction the same, right? And then find the reciprocal or flip over the second fraction. So the 2 over 1 becomes 1 over 2. And now we're going to multiply. So what does that give us?
Negative 10 over 6.
Mhm. Which simplifies because 2 goes into 10 and 6. So it reduces down to what? I didn't quite hear you. I think someone answered, I just didn't hear it. What does that reduce down to?
5 over 3.
Good, negative 5 over 3. Now we're still not done. Now we have to square that answer. But the good news is when you square it, you're just squaring the top and squaring the bottom, right? So what is negative 5 squared?
25.
And then 3 squared?
9.
9. So at least that part is a little bit better. Now we're going to take that number and do what with it?
Add it on both sides.
Good. Okay, on the right side, I like to start with the right side when it's easier. We can go ahead and add the negative 19 and 25 together, just knowing our denominator is still going to be 9. So what is negative 19 plus 25?
44 over 9.
It's not 44 because the 19 is negative, but the 25 is positive.
6
over 9.
6. Good. Now on the left side, this is an example of a problem that I probably would not want to factor because I personally am not very familiar with what multiplies together to 25/9 and adds up to negative 10/3, right? That's not a factoring problem I really want to have to do. So this is when it's helpful to know the rule, which is that you can always use what number?
2.
So it's going to be something squared, yes. But how do you know what goes inside there?
The -5 over
Would it
3.
be P minus 5/3?
Exactly. You both got it. Very good. You can always use the number you got when you divided by 2. So P minus 5/3. But we're still not done. These are long problems, right? What do we have to do now?
Square both sides.
Take the square root of both sides. So now the square root of P minus 5/3 squared, that cancels out. You just get P minus 5/3 plus or minus. The square root of 6 does not simplify, but what is the square root of 9?
3.
3.
3. Okay, so we're almost done. What can we do now to get the P by itself?
Add -5 over 3 on both sides.
So add 5 over 3 to both sides because it is negative. Yep. So 5/3 plus or minus root 6 over 3, or you could actually combine it, right? Since the denominators are the same, you could say 5 plus or minus the square root of 6 all over 3. Any questions there? I know that's pretty complicated, but we get to do one more together before we move on to the last concept. We're getting close to the end. Make sure for these problems you read the instructions, right? So what are the instructions for number 54?
Complete the square.
Complete the square. So what do you have to do?
Divide by 9.
Exactly. You have to divide by 9 and we'll do it together. You have to do the complete the square process. Whereas what are the instructions for number 55?
Using the quadratic formula.
You could do either of these problems by either method, right? So technically speaking, you would be able to solve number 54 by doing the quadratic formula, or you'd be able to solve number 55 by doing complete the square. But it is important that you follow your instructions. I'm not 100% sure what Mrs. Sarsig does, but I know many instructors look to make sure that you follow the instructions when they check your work paper. So just keep that in mind. Okay, so I agree with you. We're going to divide by 9 again. This one's very similar to the last problem, actually. Once again, it simplifies to 10/3. So I feel like a lot of ways we don't have to start from scratch here because it should remind us a lot of the last problem. So what do we do next?
Add 28 over 9 to the other side.
So now we have y squared plus 10/3 y plus blank equals 28 over 9 plus blank. Now I'm going to cheat a little bit. Since we just used 10/3 in the last problem, it just happens to be positive instead of negative, right? But that doesn't change much. What is going to happen? Well, when you divide it by 2, you're going to get positive 5/3. When you square it, you're going to get positive 25/9, right? So it's basically the same process we just did. So I'm going to go ahead and skip a step if that's okay and just fill it in here. Right, so I'll write the results, but I won't show the work. So B was 10/3. So based on what we just did a minute ago, B over 2 would be 5/3, just without the negative from last time. And then when you square it, it'd be 25/9. So you could work it out again, but we just did it a minute ago. Okay, so now on the right side, what is 28 over 9 plus 25 over 9?
$53 over 9.
Very good. And then on the left side, how does that factor as something squared?
It y plus 5 over 3.
Good. always use the number you got when you divide it by 2. Okay, how would you finish out this problem?
Square both sides.
Take the square root of both sides. So now you have y plus 5/3 equals plus or minus. The square root of 53 does not simplify, but what is the square root of 9?
3.
3. So it's very similar to the last problem, right? What's the last thing we have to do?
Bring the 5/3 over to the other side.
So subtract 5/3 from both sides. So negative 5/3 plus or minus square root of 53 all over 3. Then, since the denominators are the same, you can go ahead and combine the numerator if you would like. So any questions on complete the square before we try a couple quadratic formula problems? No? Okay, to do the quadratic formula, a couple comments. It is important that you have all the terms on the same side in descending order. So we like to say that it has to be in the format ax squared plus bx plus c equals 0. Now it doesn't have to always be x. In this case, it's m. That's fine. But you need to have the squared term first, then the term with just the variable, and then the constant, all on the same side equal to 0 so that you can correctly identify A, B, and C. So what is A in number 55?
1.
1. What about B?
-2.
And C?
-3.
-3. Now, what is the quadratic formula? We'll go ahead and do this one here, and we'll do 56 somewhere else. What is the quadratic formula?
It's -2 plus
That's not-
minus.
So in general, it's negative B plus or minus the square root
yeah.
of
The square root of b
minus 4ac all
Or
over
that's what-
2a.
Very good. And now let's plug the numbers into it. Okay, so we have -2 plus or minus what? The square root of what?
-2 squared minus 4 times 1 times -3
Good.
over 2 times 1.
Very good. What is -2?
2.
Positive 2. Good. And then what is -2 squared?
4.
-4 times 1 times -3.
Positive 12.
Very good. A little negative made it positive. All over
2.
2. Now these problems, they aren't really hard to set up, but they actually take a lot of work to simplify, right? As you can see, it's going to take many steps to simplify. What is 4 plus 12?
16.
Okay, and we keep going, right? What is
Isn't the denominator? Isn't the denominator 2 times a?
Yes. Did I mess something up?
Isn't a 3?
I think A was 1.
Oh, am I looking at the wrong? Oh, I'm looking at the wrong problem.
Yeah, we haven't done 56
My
yet.
bad.
We're still doing 55. You're fine.
Okay.
Yeah, we'll do 56 next, but we're still doing 55. So what is the square root of 16?
4.
4. So it's important, by the way, right now, the 2's do not cancel. You need to simplify the radical before you try to do any canceling. Okay, so these 2's do not just cancel out and go away. So the square root of 16 is 4. Now, since you have all integers, right, no radicals anymore, you can actually evaluate that, right? So what is 2 plus 4? 6 divided by 2.
3.
3. So your one answer is 3. And then your other answer, you have to put the minus sign, right? What is 2 minus 4?
-2,
divided by 2.
-1.
So those would have been your answers, 3 and -1. Any questions there? Okay, so let's try last but not least, number 56. What do we need to do? No ifs, ands, or buts about it as our first step.
Subtract 6 on both sides.
Exactly. Ooh, and apparently zoom in really, really far. Sometimes I think this computer has a mind of its own. Okay, so now we have 3m squared minus 2m minus 6 equals 0. And now we can identify A, B, and C. What is A?
3.
Good. What is B?
The -2.
And C.
-6.
Good. And then we're going to use the same formula, and I'd like you guys to try it out. See if you can work this one out correctly. Okay, I went ahead and plugged everything in. So hopefully we all agree right now. What is -2?
+2.
Yeah, positive.
+2, good. How about this -2 squared?
4.
And then -4 times 3 times -6.
Is that +72?
Very good. And then the denominator, 2 times 3 is
6.
6. Okay. So what is 4 plus 72?
76.
And then we need to simplify that radical before we do any canceling. So what perfect square goes into 76?
19 and 4.
Very good. So what is the square root of 4?
2.
So now that you've simplified the radical, you need to see if the overall fraction can be simplified. So is there a little number that divides evenly into the first number, into the coefficient of the radical? So not the radical itself, but the coefficient that's 2 in front and the 6. So in other words, is there a number that divides evenly into 2, 2, and 6?
Yeah, 2.
2. So you can just divide each one by 2 if you want to do it that way. I'll show you another way you can approach it in a second, but that's one way, is just divide each term by 2. So then it becomes 1 plus or minus. You don't need to write 1 times the square root of 19, right? You can just write the square root of 19 over 3. Technically, what's happening there, by the way, in case the step I did feels kind of weird to you, is I actually factored a 2 out of the numerator and then divided the 2 and the 6 by 2, if that makes more sense. That's technically what you're doing, but we don't always write it out that way. So sometimes we use the shortcut that I did instead, but that's what's going on to make it mathematically valid. Okay, so that was the last problem for today. So I'll stop sharing the screen and stop recording.